Yes.
Okay. We have been focusing on a kind of problem called mass-mass, where you start with mass of one thing and end with mass of another thing. On the mole wheel, it looks like this, sort of. Mass of one thing, convert to moles, use the mole ratio, convert it back to mole, or mass of the other thing. Okay, we only stick there. But really, for any stoichiometry problem, you can start and finish anywhere on the mole wheel. So that's what today's going to focus on. I might give you atoms to start with and ask you to finish at grams. I might give you atoms and ask you to finish at volume, et cetera, et cetera. So you can start and finish anywhere on the mole wheel for any stoichiometry problem. And oftentimes it's more convenient. A lot of times we measure mass just because in lab we measure that, so that's why we do mass-mass problems a lot. But really, you can do all sorts of kinds of problems with this, and you can start and finish anywhere, including moles, mass, molecules, and liters. Because it's, yeah, well, I don't know. Yeah, it doesn't look like a wheel, does it? It looks more like a flux capacitor. And kudos to you if you get that joke. Or reference. Yeah, that's true. That's an interesting point. Zing. You got zinged. Oh no. Got it? There were 3 steps, and I don't know if you were sort of comfortable. It seemed like yesterday a lot of people were just like learning this method. Oh, you put 1 there, and then you put the molar mass here, and then you put the whatever there. But really, it's 3 steps to solve any mole problem, and that's kind of what you want to focus back on today. So you convert something to moles, then you use the mole ratio, and then you convert it to whatever you want your answer to be in. Could be liters, could be molecules, could be mole or grams or moles. So this is from Friday. I gave you these 3 steps. Stoichiometry, stoic. When we first learned stoichiometry, we dealt with this reaction, which makes ammonia, which is a pretty heavily produced chemical in the United States. Now these things we gave on, the first day we said grams of this and grams of that makes grams of this, which is true. But actually these, at room temperature, this is a gas, and this is a liquid. So it's sometimes more convenient to think of them in liters or molecules than it would be to grams. And that's kind of what today focuses on. Obviously, you need to balance it by putting, a 3 here and a 2 here. And I might ask you questions like, I'm sorry, I can get rid of that now, can't I? So if I ask you how many liters of NH3 are produced from 50 grams of N2, that problem's a little bit different than yesterday because we're not dealing just with grams and grams, we're dealing with liters now, which means you're going to use the mole wheel a little bit differently. The same 3 steps will always apply though, and those are convert to moles, use the mole ratio, and then convert to whatever you want your answer to be in. Now if you were conscious yesterday, you're already probably grabbing for your mole wheel because this is not a lot different than yesterday, it's just where you start and where you finish. Well, you were conscious yesterday. So convert to moles first, 50 grams of N2. And if you have this right here, you're at grams, you want to get to moles. So 1 mole over the molar mass. 1 mole of N2 over the molar mass, which is 28 grams of N2. Second step is the mole ratio. The one you start at goes where? on bottom, correct, and the one you want to get to goes on top. So we're starting at N2. There's a 1 there, so we write 1 mole of N2. It's a terrible N. And the one you want to get to goes on top. That's the 2 moles of NH3, so use that. 2 moles. Remember, the second step always comes from the balance reaction. Finally, you don't want your answer, if we want our answer in grams, we would go back down to grams, but we don't want our answer in liters, and so that's where this right side comes in. Now, if you're in my class, you didn't use this very much last semester or Mr. Jell's class, which is fine. This is liters of gas, and it's at something called STB, which stands for standard temperature and pressure. You might see those terms on your homework and stuff, so don't worry about that. It just means that that's the only time this is true is when the gas is at something called standard temperature and pressure, which is the pressure at sea level and 0 degrees Celsius. So anyway, regardless, the number we need here is 22.4 liters of any gas, but in this case it's ammonia at STP for 1 mole of ammonia. That's too many. What is going on there? So then you solve it the same way you solved problems yesterday, right? $80, even. 50 times 2 times 22.4 divided by 28. He wasn't lying. It was 80. 80 liters this time of ammonia for your answer. Same kind of problem as yesterday, same sort of 3 steps. The only thing that's different is that you start and finish somewhere else on here. But you still rely on the mole wheel to tell you what math to do. All you really have to remember is what the mole ratio is. That's it. Want to try one? Good idea. Some that we don't need that there. If it's going to liters, yeah. Yep. 1 mole of NH3. That's all that you need.
Hey, Summers, I gotta steal a kid.
Is it me?
Mike.
Mike who?
Steincom.
For how long?
Just go to Erickson for scheduling.
All right, here's another problem. How many molecules of H2 are necessary to react with 14 liters of N2? You don't have to write it if you don't want to. But what would you start with to set up? Good answer, no one. You start with liters. 14 liters of nitrogen. On the mole wheel, you're right here. Liters. The first step is to convert to moles. So from liters to moles. 1 mole over 22.4 liters. That's step number 1. Step 2 is to use the mole ratio. You're at nitrogen, you want to get to hydrogen. Nitrogen to hydrogen, a 1 to 3 ratio. 1 goes on the bottom. What do I want my answer to be in? Molecules. So if I'm at moles right here on the mole wheel, I want to get back up to molecules. This is the parenthesis that I use. 6.02 times 10 to the 23rd molecules over 1 mole of hydrogen. So, to solve, we plug in 14 times 3 times 6.02 times 10 to the 23rd divided by 22.4. It is molecules. H2, molecules. I don't know where you are, mole squared.
Seconds.
23rd. Molecules. I got 1.13 times 10 to the 24th. Is that what you got?